is an instrument still largely unknown in the Western world. However, it comes from a rich history in Africa and Central America before gradually becoming immersed in Western music, film, and the dynamic world of percussion.
This project came about over a cup of coffee up in the Adelaide Hills. Professor Bailey and I had got together last summer when I was visiting Australia, which is my home, and we'd talked about some of the projects he'd been involved with in the past, building instruments, teaching percussion, and what he'd been doing in his retirement, seeing as he'd been out of the academic world for about 6 years.
I suggested an idea which I'd been thinking about for some time, that possibly UNLV percussion department could be really interested in doing. In essence, it was to design and build a 5-octave concert-sized marimba and utilizing their postgrad students and take them through the whole process.
It's the first time anything like this has really been done on a university campus, utilizing the skills of a master builder along with students at the university, sourcing the best possible products to build that instrument, and completing that project in the course of a semester so that we could actually perform on that instrument and demonstrate the quality of a recital marimba.
The process of building a concert marimba is scientific. It requires precise calculations, quality materials, and someone who understands the transcendent connection of the instrument and the expressive music that will be performed.
So the process of building marimbas is quite complex and intricate, and because you're dealing with dead but living material, in being the wood, which is the primary material, every builder has their own approach to how they might like to tune bars, the way that they want the instrument to be represented in the final product. So each builder has their own, I guess, secrets of the trade that they like to keep to themselves, because if they put it out there for everybody, then anybody, I guess, could build an instrument.
There's a 4-step process in the making of a marimba. The first one is actually laying out the plan, so you get all the dimensions and specifications that you need to make the instrument, to make the bars. Second step is the actual formation and making of the bars. Third step is going to be the actual frame, and then the final and last step is the resonators.
I've known Professor Bailey since 2010 when I first got here, and so to have kind of evolved to this stage where we're now getting to build an instrument is pretty amazing.
The building process is definitely pretty intense. Yeah, not a lot of room for error, and just sort of working pretty hard to stay on a pretty strict schedule.
To have the chance to work with the raw materials and see it go from like just slats of wood to beautifully cut, edged, and sanded, it's really awesome.
For marimba bars, the most desired timber comes from a genus called Delbergia. Of the nearly 300 species, Delbergia stevensoni, commonly called Honduran rosewood, is the most desirable for marimba bars due to its resonance, tight grain structure, and the fact that it can endure thousands of impacts from marimba mallets over its lifetime.
There are a variety of timbers that you can use for tuning. It depends really how good you want the instrument to be. The premium timber that's used is, the common name is Honduras rosewood, and it comes from Guatemala, Honduras, and Belize, mainly in that area, and it's only in those countries in the world that it grows. It has become endangered. It has been used significantly and gradually been fished out. So it is a very expensive timber to find. There are only a number of people that actually harvest it, so it is not commonplace. However, saying that, if you want the best marimba, a concert marimba, that's the timber you use.
It's becoming increasingly difficult to find good quality rosewood. The older the tree, the better. The better the grain structure, the better the quality of the sound of the bar that's finished will be.
This reply from the wood, when I hit the instrument, I can hear the reply here in my body. It's a special sensation.
I really think that this instrument has wonderful, this natural wooden sound that have some archetypical subconscious effect on our, down inside deep.
This wood is now protected, and it's very hard to get a license to bring that wood out of Honduras and Guatemala. There's very few people that have a license and the approval to do that. We were fortunate to have that relationship with Rico Franklin.
The basis of the business is to go look at every board. Look at every board in Central America before it loads. If you have any suspicion, you actually follow the container to the port until it's in someone else's hands so they can't switch it up on you. And you still have problems because you can lose wood in air drying. We air dry it 5 years. We kiln dry it down to extremely low 5 to 6% moisture. You can lose 10% in kiln drying if you do it too fast. And that's why we air dry it 5 years. Contrary to what some people like to say, you cannot tell that a tree is going to sound good or bad because you can't. Nobody can tell that. You can't actually tell if a piece of wood is going to sound good or bad until you've actually gotten it down to a key and have begun the tuning. And you really have to carry the tuning quite a ways before you can determine whether it's trash or not.
I think people always want a perfect board, but it's wild, and I don't think things that are perfect come out of the wild.
I know the roads in Guatemala, Laura and I, better than we know the roads in this state where we live. Know all the back roads. If there was a roadblock, you know how to go all the gravel highways around little towns, staying in funky little hotels. The not knowing where you're going to end up.
Well, the culture in Guatemala is really deep. It's beautiful. And the flora and fauna is incredible, and volcanoes and rivers, and it's very rich. And that part of it is and dealing with the people are really, really
very
beautiful.
Nice. The people that worked in the mills were always fun to be around. They were always the hardest working people I've ever been around. They were laughing and joking and enjoying every single day.
Taking the raw timber, the master builder must select what parts of the wood can be used for each marimba bar. He will need to mark the dimensions and carefully cut and plane the rosewood until it can be tuned precisely.
We're just going to talk about the process of actually making a bar and what you have to do. You start off with the raw timber in a plank form, and then you have to know what your sizes are going to be, obviously from your very top bar to your bottom bar on the marimba, because that will determine very often the length of all the bars in between. So the size of your top bar, your top C and your bottom C are very important, and your C sharp and your A sharp also very important, because then, as I said, they will determine every bar in the mill in terms of what their actual finished lengths will be. Now we've got this piece of timber here, which we're going to size to this bar here, which is a low C sharp. So we have to square it up first of all, and then we'll select which portion of the bar we think is going to be desirable. So the first thing is going to be just to run it through this saw. Right, so now we have the rough sawn size bar we want, now which we'll run through the planer to get both the thickness and width down to the size that we want. What we're going to try to do is to bring this thickness down to the right size. It's about 1/8 of an inch slightly oversized right now, so we'll run that through. So I'm just looking to see which way the grain runs, because it's a good idea when you run it through the planer to run it with the grain as opposed to against the grain, so the blade doesn't dig in. And in this case, it's going to go that way. Now with both pieces of wood, we've got them down to the actual thickness that we require, and now we're going to just try to get the actual width, so that we put it through the planer this particular way and bring it down to the finished size. We're now at the stage where we've sized into two rectangles the two pieces of wood to make what is going to be a C-sharp, low C-sharp bar, and then the F-sharp bar above that. Now, when we've got to this point here, what we need to do is to chamfer the edges to get a nice, slightly rounded finish. And to do that, it's quite simple. We take it to the router, which we've set up over there. So we're here at the router table. So what we're going to do is take our rectangular pieces of wood and just chamfer these very sharp corners. So here we have the two bars now through the router, as you can see, all four corners nicely rounded. So when we sand them down, we should get a really nice, smooth finish. So the next step now will be to mark off the actual length of the bars, take it to the docking saw, and then cut them to size. So after taking the ends off and making the length correct on the docking saw, what we need to do is clean up the saw marks here. And to do that, we're going to go to this belt sander and just very, very quickly just square it off and tidy it up. All right, now we've got to this point where we've done the first rough sanding. We have to decide where we're going to stamp and identify the actual F-sharp and the C-sharp.
So this should be the top, I guess, right?
Yep.
Because this is so that.
Okay, so the stamp will go on here, all right? The next step we're going to do is try and locate where the natural node points are on the bars. And why this is important is because that's where we have to drill the holes for the cords to go through and suspend the bars. Now, to try to find where the node holes are for the bars, this is the procedure. You need to suspend the bar on some wedges, take some fine sand, or you can use salt, put it in this area of the bar there and there approximately, and then as you start tapping with a mallet, you will find that the sand will start to move and congregate. That will tell you where the node point is on the bars. So you will mark that, and then when that's done, decide where you want to actually mark and drill the holes, top and bottom, to actually suspend the cords as they pass through. If you look down here, you'll see the cords that is passing through the holes that we spoke about on the nodes. And these cords have got to be able to allow the bar to move freely, which means that these pins here, you can see here, 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 and here, all the way through, which suspend the cord, have got to be perfectly in the right position in terms of where they're marked, how they're drilled, and so that this bar, as you can see, that's correct, has allowed that sort of freedom to be able to vibrate. It's really important because if they are choked in any way, you will not get a long sustain. At this stage now, we are going to mark out the actual shape of the arch on the new bar using this previous bar as the actual template. And to do that, we just make sure that they're facing exactly the same, where we have the stamps on the end of the bar facing us, putting it in that position, just holding it firmly, taking a pencil and just scribing along that line. And then when you take it out, you will see that you have a mark there, which is going to show us precisely how much timber we're going to be cutting out on the bandsaw.
The tune bar is the lifeblood of the marimba. Once tuned, it needs to be suspended to sing freely and allow the performer absolute control over tone and music phrasing.
When I've taken the material off on the bandsaw, there is still quite a bit of timber there that needs to be removed in the tuning process. So by striking there, I can see that that note is an E and it's slightly sharp. Then
by putting my hand in this position and striking there, I find that that is also an E. That's the harmonic I'm looking for, and that is just slightly on the flat side. So the first thing that we need to do is to bring those two together. So in this particular case, the fundamental is a little bit sharp, so what I'll do is I'll grind in more the center of the bar. You'll notice that when you look at the arch now, it's starting to take a better shape, it's much more balanced, and I think it's important that not only to have a nice playing surface, but also for the underside of the arch to be nicely balanced and clean. And I think it does make a difference to the overall quality of the bar in the end. Now, at this point now, we've got fundamental harmonic in line, so that part of the juggling act is working fine. Now we have to look for one other, which is this third harmonic, and that we need to try to find.
The master builder will frequently refer to a stroboscopic tuner during the fine-tuning process to keep track of the fundamental pitch and harmonics that give each note depth and character.
And there it is, I found it.
In Mexico, to say marimba and to say the last name Nandayapa, it's a lot of people, it's just like one thing. Our family history goes for 100 years, for four generations of musicians playing marimba and also marimba makers. This tradition started with my grandfather, Norberto. Also, he had 3 sons, which 2 of them were very important in the marimba history of Mexico. My father was the youngest of Norberto's 3 sons, and he became absolutely the most important marimba player in Mexico. I'm continuing also this tradition, and I had the opportunity to spread out the Mexican marimba tradition.
When building the frame for a concert marimba, both aesthetic and functionality need to be considered to ensure a musical instrument capable of achieving a broad but refined sound.
Today we're working on the frame for the instrument, so the end pieces and the rails, the bars all fit in, and the resonators go on there, and it's the main structure that holds the whole instrument together.
You will then, first of all, need to select what timber it is you want to do it in, how you want to do it. I mean, you don't have to do it in timber, it could be done in metal, it could be done in a whole lot of materials, but generally it tends to be timber. And then you will then take these rails. They tend to be about 3 inches wide, about 1 inch thick. Most of them have a hinge in the center, which means that when the rail is detached, it can fold up like that, which is easy for transportation. And of course, you have 4 of those. So when you get into the frame, it's not only about its function, but it's also about its appearance. So you're getting into the cosmetics of making the instrument. And that can vary depending on your imagination and what it is you want to do. Do you want just a functioning instrument that is quick and easy to set up and take down, or do you want something that's going to look like a Steinway? So it depends entirely on you. When you are making these rails and locating these pins, now these pins here are what actually supports the chords which go in line with the node holes that you've drilled on your bar. The positioning of these pins and the positioning of these rails is absolutely crucial in terms of accuracy, because if they are not accurate, then they will not line up with the holes on the bars, and therefore the whole thing will just be, well, it just won't work. The bars will not simply sit on those supporting pins accurately, and they need to be not only accurate, but they need to be sitting fairly freely so they can vibrate. Otherwise, they will be totally choked up. So you need to do that. That's where the master plan is very important in being able to accomplish that.
I discovered it relatively lately. So first I was snare drum and percussion and drums and everything. Marimba come into my life relatively late. But immediately I find out, I felt first that sound is excellent, second that technical and musical possibilities of this instrument are enormous. I can clearly see that it has developed and is developing enormously. When I started studying, it was 1980. In Yugoslavia, which is formerly country doesn't exist anymore, there were not one single private instrument. There were no person in the entire country of 20 million who has owned marimba. But in every second household, you have had piano or violin. So I was the first person in socialistic Yugoslavia to own privately 4.5 octave marimba.
Resonators, tuned to each bar, amplify the sound and bring the marimba to life.
The third process are the resonators. These long line of pipes that you see at the front and on the back of the instrument. They are very simply nothing more than an amplifier. It is a tube which has a plug inside, an airtight fitting plug. Now if you look in the end of the resonator, you will see that it's blocked off with a plug. And we have to do that because it's what's termed a quarter wavelength resonator.
A quarter wave resonator is a closed resonator tube tuned to the fundamental note of the bar that is positioned above.
This resonator needs to be tuned exactly to the same frequency that the note it is going to sit below. So if you can imagine there's the note, there's the resonator, and the mouth sits roughly about an inch below the curve of the bar. When they are both perfectly in tune with each other, you will get sympathetic resonance. You will hit the bar will then shoot the sound into the resonator. Because the resonator is at the same frequency as the bar, the sound will then explode up. So it becomes a marriage of the bar and the resonator. When the two are perfectly in tune with one another, that's when you will get the absolute maximum amplitude of that particular note. So you can begin to understand now why the tuning of the bar and the harmonics and the resonators, which are the most important aspects of building a marimba, are so important to be accurate. Now, the purpose of this plug is to be able to tune the resonator. It needs to be airtight, and for the most part they are movable, which means as you move it up the resonator, of course you are going to increase the pitch. As you move it down the resonator, then you're going to lower the pitch. That's where the real characteristic sound of the marimba is. So the tuning of these resonators is very, very important in terms of their accuracy. The elbows that we wanted to use on the bottom notes and the bottom octave are much larger than we wanted. And so the problem is going to be how we can either utilize them, or maybe we might even have to sort of change a slight design direction. There's always the problem of trying to source the right material, the suppliers, where you can get what you actually need to make the instrument. And sometimes that can be a bit frustrating because it does take a lot of time. Because again, you have to make sure that what you order is exactly what you want. But we're getting there, and I'm sure in the next few days we'll have most of it solved, and then it'll just become a dream, and we won't worry about it too much when it's finished.
This marimba building project that began as a pipe dream idea in a small Adelaide Hills town brought a unique artistic collaboration between students and faculty on the UNLV campus, and enthusiastic contributions from marimba experts in the United States, Mexico, Serbia, and Australia.
I don't want to say it was like some supernatural connection to the instrument, but it was just that realization when the sound came out and I felt my mallet hit it. I just went, whoa, you know?
It still doesn't feel real. Like I just came off stage playing it, but it doesn't feel like the project is done because it's been go, go, go every weekend, every day.
It's an excellent experience being able to build the marimba and now finally have it completed. To be able to perform it on this stage, which is our recital space, is particularly special.
Playing this marimba felt super great. We've been working on it for about 3 months now. To finally be able just to sit back, relax, and just play on the marimba that we've been building is so great.
We always knew we'd get to the end of the project, but to actually see the marimba uncovered, the resonators, the bars, the frame, everything finished, right down to the touch of having Professor Bailey's signature on the front, it was a really impressive moment.
It's been a fairly intense 4 months to get at that point, and it hasn't been the easiest of processes, but as often is the case, when you finally see the instrument there, it's finished, and you hear it, and it does everything that you hope it would do, then that's a great source of satisfaction to see that.
So marimba has developed enormously.
For percussion students, the marimba is really our piano. This is the instrument where we develop the skills of harmonic and melodic structure. We develop the skills of controlling rhythm and tempo and dynamics, and then learning how to phrase and breathe with music.
I think now it's a lot of new generations of marimba players.
I love the sound of marimba. Laura loves the sound of marimba.
I am now in the position in my life where I am gladly expecting that hopefully the fruits and the seeds that I have thrown in the 90s and the beginning of the 21st century, that some younger kids who are 25, 27, 26 or 30 and spending 8 hours in practicing rooms and thinking and breathing and eating marimba bars and smelling them and sweating above them, it's their job now to bring it to the next level, and we are already seeing it. I see myself, 2 decades ago when I was doing this and that, it was wow. Now everybody is doing it.